Have you ever stopped and wondered how your smart assistant or a chatbot actually follows what you're saying? I mean, not just understanding one command, but really following the thread of a conversation, sentence by sentence. Well, today, we're going to dive deep into the incredible and incredibly complex challenge of teaching a machine the real art of conversation.
So that's really the big question, isn't it? How does a computer follow a story? For you and me, it's just second nature. But for a machine, this is one of the toughest nuts to crack in all of artificial intelligence. How on earth does it connect the dots from one idea to the next?
Look at this super simple example. A dog chased a cat. It climbed a tree. We know instantly that it is the cat, but a computer. How does it solve that little puzzle? How does it know it isn't the dog, or maybe the tree itself? This tiny two-letter word, it opens up a massive challenge. All right, to unpack this, here's our game plan. We're going to start with that big challenge of context. Then we'll meet the hero of our story, Discourse Representation Theory, or DRT for short. After that, we'll see why language desperately needs rules, how AI deals with our very human vagueness, and finally, we'll tie it all back to the AI you probably use every single day. So first up, the challenge of context. This is really the fundamental hurdle that AI researchers have been trying to get over for decades. Getting a machine to understand not just the words, but the little world those words are creating. You know, the AI pioneer John McCarthy saw this problem coming from a mile away. He pointed out that AI systems tend to be specialists. They're amazing at one specific task, but they lack that general common sense reasoning to take what they know from one situation and apply it to another. So where do you even begin to fix that? Well, first, you have to teach the machine what context even is. Logicians came up with a way to formalize it, to turn it into a rule a computer can understand. They developed this logical notation that basically says, hey, computer, this fact is true, but only inside this specific conversation. It's like putting a little bubble around the dialogue, and it was the very first step. And that leads us right to our main event. To solve this problem of following a story, a really powerful new idea emerged: Discourse Representation Theory. You can think of it as the specialized tool AI built to give itself a memory for conversations. So what is DRT, really? The best way to think about it is as a set of instructions for building a running summary of a conversation. Its whole job is to listen to each new sentence and then figure out, okay, how does this new piece of information connect to everything I've already been told? So here's how it works. Picture the AI creating a little memory box for our story. It reads sentence 1, a dog chased a cat, and it puts a dog, a cat, and the fact that they're chasing into the box. Then sentence 2 comes along. It climbed a tree. The AI looks inside its box, sees the cat, and correctly links this new action, climbing a tree, to it. This little memory box is just constantly being updated as the story goes on. And this right here is such a crucial point. DRT's job is to understand the logic inside the story. It knows it is the cat in this specific narrative. That's a totally different job from a general knowledge base, which stores facts about the world like, cats in general can climb trees. A smart AI actually needs both of these tools to really make sense of our language. But just having a memory box isn't quite enough. For an AI to understand language quickly in real time, it also needs to follow some very strict rules. Otherwise, the whole process would just be too slow and chaotic. It really all comes down to a trade-off between how complex you make it and how fast it can run. Which leads us to this core idea. For language processing to be tractable, which is just a fancy way of saying doable in a reasonable amount of time, it has to be compositional. And all that means is that the meaning of a whole sentence has to be built up from the meaning of its individual parts in a predictable, orderly fashion. Honestly, it's just like building with Legos. You gotta follow the instructions piece by piece. And this is exactly why those rules are basically non-negotiable for AI. A compositional rule-based system is fast and orderly. If you try to do it any other way, you get what's called a computational explosion. The number of possible interpretations just skyrockets, and the whole system would grind to a halt. It becomes completely unmanageable. Now, of course, DRT isn't the only tool in the toolbox. It's actually part of a whole family of these formal systems. You've got things like multinets that try to work across different languages, or logic programming like Prolog. They all tackle the problem from slightly different angles, but they're all chasing the same goal: to make our messy, human language make sense to a purely logical machine. Okay, but this brings up another massive problem. All of these systems, they love logic, they love precision, But what about us? Humans are anything but precise. So how does an AI deal with our natural vagueness?
I mean, think about it. Words like tall, warm, or soon, they don't have a strict mathematical definition. What I think of as warm might be totally different from what you consider warm. So, for a machine that thinks in absolute ones and zeros, how in the world do you compute the meaning of soon?
Well, the answer comes from a really fascinating field called fuzzy logic, and specifically something called axiomatic fuzzy set theory. It's basically a mathematical framework that was built from the ground up to handle these shades of gray. It lets a computer reason about ideas that aren't strictly true or false, but somewhere in the middle, just like we do all the time. It's the perfect bridge between our fuzzy human world and the computer's precise logic. Whew, okay, we have covered a lot of ground here, from context and memory boxes to strict rules and fuzzy logic. But this brings us to the most important question of all. Why does any of this abstract theory actually matter for the AI that you use every single day? It's because every single time a chatbot perfectly understands your follow-up question, or a smart assistant remembers what you talked about 5 minutes ago, it is standing on this deep, hidden foundation. All these formal systems, they're the invisible skeleton, the logical bones beneath the conversational skin that lets modern AI feel so incredibly fluid and natural. And that really leaves us with one last thought to chew on. We have made unbelievable progress in teaching machines the rules, the structure, the pure logic of our language. But the big question that remains is, can they ever learn its soul? The emotion, the creativity, the real intent behind our words? Well, that's a question for another day.